Europa probably has beneath its icy surface a global ocean of water. Everywhere on Earth that there's water, there's life. So we want to understand, could Europa be a place where life might exist today? Does it have the ingredients that could potentially support life?
The ocean is so meaningful for life on Earth, and it brings such a sense of massiveness. And I think once we get to Europa, like thinking about this subsurface ocean, it's not quite the same as we think of oceans on the Earth where you got waves and such, but we also need to step back and look at it as this is a world with an ocean, possibly with habitable environments, and to be able to think about that as a connected system again, just like on the Earth, and the kind of the massiveness of that, and also how that then will tell us about other bodies in our solar system or other bodies outside of our solar system.
The question of plumes on Europa has bedeviled us for a while now. The Hubble Space Telescope looked at Europa in the ultraviolet, and they saw evidence for oxygen emission and hydrogen emission near the edge of the moon, and they're thinking, well, this is probably due to water, and so probably evidence of some kind of plume activity. But it wasn't there every time they looked. Sometimes it was there, sometimes it wasn't there. And so, controversial. There was a reanalysis of Galileo data, and the Galileo also hinted that there was some kind of potential activity there. But again, it wasn't definitive. Europa was a key target for us with JWST to look to see if we could see a plume because we have such great sensitivity. We did not see a plume at Europa with JWST. We saw other interesting things, but not a plume. Does that mean it's not there? Maybe, maybe not. Maybe this plume is episodic. Maybe there's only certain configurations where it is active.
So I first got excited about using JWST when I was a grad student at Caltech. I hadn't launched yet, it wasn't available yet, but the build-up was so exciting. We were really interested in this question of the CO2, which you just cannot access through Earth's atmosphere. JWST gives us access to all of those wavelengths that we can't access through Earth's atmosphere. So there were two independent teams looking at this Cycle 1 JWST observation of Europa, and so we downloaded it as soon as it was available. I think it was right after Thanksgiving. I was actually at my parents' house. In between, making stuffing and carving the turkey, I was looking at these data and trying to test if our prediction was true. And it turns out that it was, so it was very exciting. The significance of this carbon result is that it's really another data point on what actually is probably within Europa's internal ocean.
And that's the main idea. Is that ocean habitable? We needed to find where the carbon was stored, and if there's a carbon source on Europa, especially in the ocean.
People think as an astronomer that you spend your life, especially your nights, outside at your telescope. I guess they think you have one at your house or something, I don't know. But when you're using professional telescopes, you typically get a tiny piece of time, maybe 45 minutes for the year, maybe 2 hours for the year. That's not a lot of time. And so there's a lot of questions that you can't answer when you only have tiny snapshots. That's the data that you get, and that's what you work with. It'll take a lot more observations, and it might have to wait until we get spacecraft back in the system.
So Europa Clipper is NASA's flagship mission to Europa, and it has everything on there that you would want as far as instrumentation to be able to study a moon and to figure out what's going on there as far as the geology, what's going on in the interior. And my role on Europa Clipper is as a team member on the Europa imaging system, and so that's the camera team. And so what we're going to do is try to take high resolution images of Europa's surface, higher than we've ever had before, and we are also going to look for the geyser-like plumes that the Hubble Space Telescope has observed and see if we can image those up close. So it's really full circle going from Voyager to Galileo with a little bit of the Hubble Space Telescope mixed in, JWST, and now Europa Clipper. So we're very excited. In October 2024, the Europa Clipper spacecraft is going to launch from Cape Canaveral, and it's going to be on its way to the Jupiter system. The fractures on Europa, some of them are thousands of kilometers long. And if you look at a picture of Europa's surface, they're just crisscrossing the surface. I mean, these are not just small fractures. These are fractures that would put the Grand Canyon on Earth to shame. So these are just massive fractures, and again, many of them form because of tidal heating, because of the gravitational pull of Jupiter on Europa. So that just shows you how powerful Jupiter is and how much bigger it is in Europa. So we have organics, we have water, and we have energy, 3 of the necessary ingredients for life. So Europa looks like a good place to look for habitable environments.
So now that we know that there is a carbon source, now we can go deeper, and I think it will help a lot with Europa Clipper and more observations, deeper integrations with James Webb. We are allowed to see other carbon compounds, for example methane or ammonia, which is an antifreeze. So as we now looking for more compounds, we can learn about the chemical diversity and some other processes that help with the habitability of the surface and the ocean.
We were so honored that the National Poet Laureate Ada Limon wrote a poem about Europa and Europa Clipper.
Arching under the night sky, inky with black expansiveness, we point to the planets we know. We pin quick wishes on stars. From Earth, we read the sky as if it is an unerring book of the universe, expert and evident. Still, there are mysteries below our sky. The whale song, the songbird singing its call in the bough of a wind-shaken tree. We are creatures of constant awe, curious at beauty, at leaf and blossom, at grief and pleasure, sun and shadow. And it is not darkness that unites us, not the cold distance of space, but the offering of water. Each drop of rain, each rivulet, each pulse, each vein. Oh, second moon, we too are made of water, of vast and beckoning seas. We too are made of wonders, of great and ordinary loves, of small invisible worlds, of a need to call out through the dark.
The collaborative experience of being on Europa Clipper is pretty amazing. You have scientists who were around when the Galileo spacecraft, who were actually on, team members on the Galileo mission. And so they have this vast amount of knowledge about Europa, and any question, just about any question you ask, they could answer. And so it's so amazing. But then you have those of us who, when the Galileo spacecraft was at Europa, who were in middle school. When we come in, we have these new ideas, and so just the mesh of the folks with the wisdom and the experience from the Galileo mission era, and those of us who are newbies and kind of coming in and having mentorship from them, but also having our own ideas, it's been really great. My first experience with science, at first I didn't really like science when I was in middle school or junior high school, as people call it, but I got to high school and I took a very, very good honors biology course. And so at that point, I was pretty much stuck on biology. I wanted to have some sort of job where I could use biology. I wanted to be a marine biologist or a doctor or something like that. And that's the track that I wanted to go on. And then my junior year in high school, I took an earth science course where one of the units was astronomy. And so we learned about the life cycles of stars and how they die and they can go supernova, and some of them become black holes. And I was hooked, and I could not believe that people actually got paid to study things that were that cool. And along the way, I spent a summer at the Johns Hopkins University Applied Physics Lab studying Europa, and completely fell in love with planetary science. And I really fell in love with Europa.
So we have all these missions going there to explore these moons in detail, but where are we going to go? What are we going to find? What is the best way to explore these moons? One day maybe sending humans to Europa.
People have thought about, what might life on Europa look like. Of course, on Europa, there's no sunlight penetrating through that ice shell, for photosynthesis in the ocean. So it has to be life that's independent of sunlight. And on Earth, the most analogous environment is probably hydrothermal vents at the seafloor. So places where seawater is interacting with seafloor rock.
2023 has been an amazing year for JWST. It has seen so much science starting to pour out of the telescope and into papers that are now being published. So what an exciting time for someone like me who's been waiting and watching for 20 years. This is the year where the science has started to flow.